In the previous session, we understood how to balance a chemical reaction, and we also balanced two different equations. The first equation that we balanced was, we took a simplest equation where magnesium was allowed to react with oxygen to form magnesium oxide, and the second equation that we took was, we have taken zinc, which was allowed to react with HCl to form zinc chloride plus hydrogen. We balanced them and obtained a complete balanced equation, correct? And now in this session we will try to balance 9 different chemical equations, and let's look at how each one could be balanced in different ways, right? Let's take the first equation here, that is zinc is allowed to react with sulfuric acid, that is H2SO4. When this reacts with H2SO4, we get a product that is known as zinc sulfate plus hydrogen gas. Okay, the first step in looking how to balance the reaction, check if this particular equation is balanced or not. So only then we can proceed with balancing this equation. So let's look here. What are the elements here? Zinc is present, hydrogen is present, sulfur is present, and oxygen is present. Now in the reactant side, how many zinc are present? There is only one zinc here, whereas here on the product side also only one zinc. So zinc is balanced. Next, let's take hydrogen. There are two hydrogens here, whereas here there are two hydrogens. So hydrogens are also balanced. Then how about sulfur? Here it is one sulfur and there it is one sulfur. So sulfur is also balanced. Then the last one, that is oxygen. Here there are 4 oxygens on the reactant side, and here also there are 4 oxygens. So all the atoms are balanced on the reactant and product side. Hence, in this case, the skeletal equation has become a balanced, completely balanced chemical equation. So this is a complete balanced chemical equation. You understand this? Let's take one more example. Here we will take, do you remember we have taken one lead nitrate solution and into which we have added potassium iodide, and I also discussed the significance of this reaction, which you would do this in grade 11th also, that you get a yellow colored PPT, that is like PbI2 plus KNO3 is formed. Now if you look at this reaction, this is a skeletal equation. Let's see whether this skeletal equation becomes a balanced equation or not first. So if you look at the reactant side, you have here lead, nitrogen, oxygen, potassium and iodine. Now on the reactant side, you have how many lead? One lead, and the product side also one lead. So, okay, so lead is balanced. Whereas in nitrogens, here there are NO3, that is N1O3, that is 1 into 2 is 2. Here nitrogens 1. So this is not balanced. Oxygens, 3 2s are 6 oxygens, whereas here there are 3 oxygens. And how about potassium? K1I1, that is 1 potassium here. Here also K1, 1 potassium. So this is balanced. Whereas oxygens are also not balanced. Then how about iodine? Here it is 1 iodine. Here there are 2 iodine. So this is also not balanced. So this equation is a skeletal equation. Then how do you balance this equation? We learned about different steps in balancing a chemical equation. The first step is you should never touch, that is anything inside a chemical formula. That means no number inside this box should be manipulated. You cannot change any number inside this. And you cannot write anything in the subscript or superscript also. The only place you can write or you can change some numerical is only the stoichiometric coefficient. You have to utilize the numbers that are stoichiometric coefficients in balancing this chemical equation is the first thing you have to keep in mind. The second thing that you have to do is you should know what to balance first. So you have to balance something first. correct? So what should you balance? So in getting to know that, you have to keep in mind that you have a lot of compounds in this particular given reaction. So lead nitrate is one compound, potassium iodide is one compound, lead iodide is one compound, and potassium nitrate is one compound. So you have to look at the compound which has maximum number of atoms. So which is the compound that has maximum number of atoms? Here there is lead 1, nitrate has 1 plus 3, that is 4, 4 twos are 8, and 8 plus 1, total 9 atoms here. Here there are only 2 atoms. Here there are 3 atoms. And here there are 3 plus 1 plus 1, that is 5. So first you have to start balancing the atoms which are maximum in a compound. So now here in the compound that is 9. So you will start balancing with this compound. In this, which atoms should you balance is the question. So you should balance the compounds which are maximum in number. So if you look at this compound, oxygens are 6, nitrogens are 2, and lead is 1. So first you will balance with oxygen. So I have to balance first oxygen. So now in balancing oxygen, from my equation, on the reactant side I have 6 and on the product side I have 3. So that means I have to make them equal. So that means if there are 6 here, I have to ensure that there are 6. So how do I make on the product side 6 oxygens? Already I have 3. The only thing I can manipulate is the stoichiometric coefficient, which is already 1 here. So if I make it 2 into 3, then it becomes 6 oxygens. So I make 2 into 3 oxygens which are already present. So my new equation will become PbNO3 taken twice plus Ki plus Ki. This will give rise to PbI2 plus 2KNO3. Correct? So now oxygens are balanced. Now after balancing oxygen, let's try to balance the other atoms present in this given compound. Let's take nitrogen next. So if you look at nitrogen in this compound, on the reactant side, you have how many nitrogens here? 2 nitrogens. So this is now your new equation. So here there are 1 into 2. So there are 2 nitrogens on the reactant side. How about the product side? Here 1 into 2. Here also there are 2 nitrogens. So if you look at this, the number of nitrogen atoms on the reactant side and the product side are both equal. So that means that nitrogens are also balanced. Then look at lead. So if you look at lead, here there is 1 lead, here also 1 lead. So that is lead on the reactant side it is 1, product side also it is 1. So hence my lead is also balanced. And then let's look at the next, that is potassium or iodine. Let's take potassium here. So if you look at potassium, so on the reactant side, the number of potassiums are how many here? 1, because this is my new equation. And my product side, the number of potassiums are 2. So that means I have to balance potassium. So now to balance potassium, I have to make it 2 here. So now how do I make the number of potassiums on the reactant side 2? I can only manipulate the stoichiometric coefficient, which is already 1. So that means I have to make the stoichiometric coefficient 2. So how do I make it 2? I will multiply this with 2 into 1. So this becomes, my new equation will become PbNO3 taken twice plus 2Ki, which will lead to the formation of PbI2 plus 2KNO3. Now see if the potassium is balanced. 2 potassiums balanced. Then how about iodine? So this is also balanced. So the last one that is left is iodine. Now on the reactant side in this equation I have 2. On the product side in this equation I have 2. So my iodine are also balanced. Hence this equation becomes my final balanced equation. So before you confirm this, you have to check once again. Here there is one lead, here there is one lead. Here there are two nitrogens, here also there are two nitrogens. And six oxygens, two threes are six oxygens. Two potassium, two potassium. Two iodine, two iodine. So now I can confirm that this particular reaction is balanced. You understand this? Let's take one more example. We have taken 1 and 2. And the third one we will take reaction of iron with steam. What is steam? Is nothing but water, correct? When steam reacts with iron, it will result in the formation of Fe3O4, which is an oxide plus hydrogen. This is a mixture oxide. This is a mixture of two compounds. Keep in mind, this will help you in your higher grades. This is a mixture of FeO plus Fe2O3. That is the reason you write it as Fe3O4. Fe, 1 Fe, 2 Fe. So 1 plus 2, 3. 1 plus 3, 4. You understand this? Now, how to balance this reaction? Let's see first if it is balanced or not. So what is present here? Ions are present, hydrogen atoms are present, oxygen atoms are present. Now on the reactant side, how many ions do I have? 1. On the product side, total 3 ions. Then how about hydrogens? 2 hydrogens on the reactant side. Product side here, 2 hydrogens. So these are not balanced, whereas this is balanced. How about oxygens? Here there is 1 oxygen. Here there are 4 oxygens. So now here it clearly says that this is also not balanced. Correct? So we have to balance this equation, which is a skeletal equation. So now first thing in balancing, we have to ensure that we do not disturb any of these entities. Okay. The next step is to check which compound should I balance first. In the compound, which atom should I balance first? So in checking that first, I'll try to figure out the number of atoms present in each reactant and product. Here there is 1. Here there is 2 plus 1, that is 3 atoms. Here 3 plus 4, that is 7 atoms. Here there are 2 atoms. So first, which one will I balance? I will try to balance this compound. Now in this compound, which atoms should I balance? So I should balance the atoms which are maximum in number. So what are the atoms that are maximum in number here? Oxygens. So now oxygens I have to balance. So now in balancing this oxygens, let's take what are the things that are present in the reactant and the product. So what is present in the reactant here? 1 oxygen is present in the reactant, and how many on the product side? 4 oxygens. We have to make here also 4. So that means to make this 4, I have to multiply this 4 into 1, and here also it is 4 now. That means on the reactant side I have 1 ion, so 1 oxygen. I have to multiply, I have to change the stoichiometric coefficient here to 4. So my new equation will be what? Fe plus 4H2O will become Fe3O4 plus H2. So this becomes my new equation. Now from this equation, if you look, oxygens 4 oxygens balance. So next I have to balance iron. Now to balance iron, how many ions are there on the reactant side? 1 ion. And how many on the product side? 3 ions. So I have to make it equal. That means I have to make it 3 and 3. Now how do I convert this 1 into 3? I have to multiply this 1 by 3. Only then it will become 3. So in the reactant side only 1 ion is present. So I have to make it 3. So my new equation will be 3Fe plus 4H2O will result in the formation of Fe3O4 plus H2. This is my new equation. Now what is left to balance? We have balanced oxygens, ions, and how about hydrogen? So if you look at hydrogen, on the reactant side you have 8, on the product side you have only 2. So that means you have to balance hydrogens also. How do you balance this? So here you have 8, you have to make it 8. So to make it 8, you have to multiply this 2 by 4 into 2. Then it becomes 8. You understand? So my final equation will be 2Fe plus 4H2O forming Fe3O4 plus 4H2. This becomes my complete balanced chemical equation. You understand this? So it is balanced. So we have solved how many? 3 equations, and we are left with 5 more. Correct? We will do it in the next session. Thank you so much, and I'll see you in the next session.